Hello, everybody. Let's talk about the simplest kind of experimental design called a completely randomized design. And we'll focus on a particular part of the story this time. We're building on what we learned last time. So if you remember last time, I had a hair growth formula, and I wanted to conduct a simple experiment. So I had a population of interest, and I randomly sampled from them, and then I assigned my participants to either a control group which did nothing, or a test group which rubbed my hair growth formula in. And then at the end of the experiment, I would measure the hair growth of both groups. And if there was a difference, if the test group had greater hair growth, I could say, oh, great, it looks like my hair growth formula works. Okay, so there is an effect that we talked about called the placebo effect, which is about how the expectations of the participants can affect the outcomes. And so today we're going to focus on how to control for the expectations or the beliefs of people in the experiment. Wow, it would be great if that fit on the line. And so the people could be either the subjects who are part of the experiment, or it could be the experimenters themselves. So if we are going to try and control for the effects of people's expectations or beliefs, this is called blinding. And you might have heard of a double-blind experiment as being like the gold standard of scientific experimental design. And so we'll talk about what is single blinding, what is double blinding, kind of how do you do it. So as an example, to start off, let's think about designing an experiment to test the effectiveness of medication versus talk therapy for depression. Those are both kind of common ways of trying to address depression. A lot of studies have looked at both. So the population of interest would be people with clinical depression. And that word clinical depression is just to differentiate from the ordinary English word of depressed, meaning something like sad. So clinical depression would be like the diagnosed condition of depression. So that's our population of interest. Just like last time, we randomly sample, and we end up with some experimental subjects. Think if you can remember what we called these last time. It was 2 words. They were experimental units. But when experimental units are people, we call them subjects. So let's say that we end up with 108 volunteers. So that's who our subjects are. So let me introduce you to a couple new pieces of vocabulary. So before we talked about an explanatory variable. Once you're talking about experimental design, that's often called a factor. So let's say we're only going to look at talk therapy. So the factor is talk therapy, like did they participate in talk therapy or not. The factor levels are all of the values that this variable could take. So it could be like yes or no, like they participated in talk therapy or they didn't. Or there could be several different levels. So let's imagine an experiment where we have once per month would be one level. Twice per month would be a different level, and 4 times per month would be a third level. So again, a factor up here is the controlled explanatory variable. It's the thing that we're going to hope has an effect. And then the factor levels are the possible values for that variable. Okay, so let's talk about treatments now. So once we've got our subjects, we're going to assign them to a control group or a test group. The treatments are the names for the different test groups, specifically what each test group has to do. So here we would have 3 treatment groups, 1 for each of the factor levels. So let's draw 3 treatment groups. And then we'll have a control group here. So let's call this once per month is treatment 1. Twice per month is treatment 2. 4 times per month is treatment 3. And then we have a control group. And we'll talk in a second about what does the control group do. But the term treatments specifically refers to what each of the test groups is going to do as part of their test. Okay, so if we have 108 volunteers, remember we want to randomly assign them to these 4 different groups. Remember why it's important that they're random, and what are we trying to achieve with the randomness. So the reason it's important that they be random is we want all of these groups to be the same as each other in all respects, so that way if there's a difference in outcome, we can say, oh, the difference in outcome is because this group did it twice a month and that group did it once a month. We can attribute the difference in outcome to the treatment rather than saying, oh, there's something else about this group that explains why their outcome was different. So 108 volunteers divided by 4 is 27. So I'm going to write 27 people here. This is PPL for people. And then this is random assignment. So each of the groups does whatever their treatment is, or the control group, and then we'll compare their outcomes. We know what the explanatory variable is. It's the amount of talk therapy. What's the response variable? So the response variable here, it might be something like severity of depression, but we need a way of measuring that. And because I'm not a psychologist, I don't know what the measure is, but I presume that they're standard instruments. They're standard tools that you use to measure severity of depression. So this is a place where humans play a role. Humans play a role in administering the treatment because they're actual talk therapists who engage in the therapy. And then there are humans over here, which we'll call evaluators. So evaluated by evaluators. And they're the ones who decide at the end, like, what was the severity of depression in each of the groups. Okay, so now let's talk about blinding. So what we're doing when we're blinding is we're trying to control for effects having to do with people's beliefs rather than effects due to the actual therapy itself. So let's define placebo effect. If you look it up on the internet, there are various similar definitions. I think we'll define it here as a positive effect. I guess it's usually positive. A positive effect due to belief one is receiving a treatment. So it's not due to the actual treatment itself, it's just due to your belief that you are receiving a treatment. And that, for many people, results in some type of positive effect or positive outcome. So, for example, So, for example, instead of talk therapy, let's say that we were going to tell people that we had a beverage that they could drink that would alleviate depression. And let's say the beverage is just sugar water, and we conduct an experiment. You would very likely see a small effect where the treatment group that was drinking the sugar water would probably have a slightly better outcome due just to the belief that they were receiving a treatment, when in fact the treatment was probably not actually doing anything. Okay, so how can you control for this? Controlling for the placebo effect usually involves having the control group take what's called a placebo. And a placebo you can think of, let's do a 2-word definition. So a placebo is a fake treatment. In other words, it's similar to the real treatment, but without an actively beneficial element. So whatever it is about the treatments that's supposed to be causing the changes, the placebo won't have that. So for medications, it's common for the placebo to be a sugar pill, for example. Okay, so now let's think about what would a placebo be for talk therapy? Like, how could you have the control? So, like, you might imagine that the control group just doesn't go to any therapy session at all. But in that case, the people who are receiving a treatment know that they're receiving a treatment, and the people who are in the control group know that they're in the control group because they're not receiving the treatment. So how do you control for that? For this particular example, it might be hard to control. If we were trying to evaluate the effectiveness of a specific kind of talk therapy, one thing the control group could do is meet with a fake therapist who just asks the same series of questions, which is just like them talking about their day or some other neutral thing that's different than the talk therapy that's supposed to be beneficial. So unless the subjects themselves have done talk therapy before or are familiar with the type of talk therapy that's being evaluated, everybody would think they're receiving the treatment. The control group is like, oh yes, I went and I talked to a therapist. And these other people, in fact, did talk to therapists. And so all of their beliefs would be the same. And so in that case, if there was a difference in the outcomes, it couldn't be because one group believed that they were receiving a treatment and another group didn't. So that's what would be called a single blind design. A single blind design is when the subjects are quote unquote blind. That is, they don't know. The subjects are blind to what group they're in. So in other words, they don't know and they can't guess if they're in a treatment or control group. I probably should have written in that can't guess part because that's important. Because remember, just the belief that you're receiving a treatment is enough to induce the placebo effect. So even if they haven't been told that they're in a control group or you've tried to blind them by giving them a placebo, if they could reasonably guess which group they're in, there could still be a placebo effect. And so I was talking to my sister who's a doctor, and she said it's pretty common in medical studies to have a post-survey where you survey the participants and ask them if they believe they know what group they were in. And then you treat those people separately if they guessed correctly about what group they were in. So let's add one more note. The most common way of doing a single blind design is by giving a placebo to the control group. Okay, but remember, there's another group of humans here. It's not just the people who are subjects in the experiment. They're also the experimenters themselves. So let's take a look at the evaluators over here. Let's say that the evaluators who are in charge of determining the severity of depression are the same people running the overall experiment. I'm not saying that, well, so, on the extreme end, you could imagine unethical experimenters who are intentionally, like they know which subjects were in what groups, and so they're intentionally fudging the outcomes. They're intentionally saying, I'm going to evaluate these people as a little bit less depressed than these people or these people in order to get the outcome they want. I think that that's pretty uncommon. What's a lot more common is for there to be subconscious influences or other types of unintentional cueing. So the best way to double blind your experiment is by also ensuring that the people administering and evaluating the experiments don't know who's in what group either. So that way their beliefs can't influence their judgments about the outcomes. So let's add that as a note. Double-blind design is when the experimenters also don't know who's in which group. So their beliefs can't have an influence. Okay, so how would you do this kind of blinding in practice? It depends on the type of experiment that you're doing. A common thing you could do is you could have the evaluators be a separate group of people. Even that is not necessarily safe, though, because if the evaluators are separate from the experimenters, but they still know who's in what group, they might have private beliefs about the effectiveness of talk therapy. And those beliefs could influence. So what's better is to just assign all the participants numbers, and we keep information about which numbered participants are what part of which groups completely separate from anybody who's conducting the experiment. So from the perspective of the evaluators, all they know is I'm evaluating person number 5, I'm evaluating person number 28, but they don't know if person number 5 is part of this group or that group. They don't know where person 28 is. So they conduct their evaluations blind, and then only later do we put together all of the information in one place. Okay, so like on an FRQ, if you were going to be writing down your experimental design, you would want to mention your population of interest, how you were sampling to get your subjects, what the factor and the factor levels are, and then for blinding, you would say single or double, or you could say unblinded if you weren't blinding your experiment, and you'd probably have to describe how. And then you would say that you were randomly assigning your subjects to the treatment groups and the control group. You would describe which treatment each group is doing, and then you would have an illustration showing how you're going to compare your results. And in this case, the results are simple. We're just comparing the outcomes of all 4 groups. But later on, when we have more complex experimental designs, this process will look a little bit different. Okay, let's flip it over, do one more. So I want to show you something called a multi-factor design, just to illustrate the difference between the factor levels, and treatments. So on the front page, remember, factor was our explanatory variable. The factor levels were the different possible values for that variable. And each factor level became its own treatment. It became its own thing that a test group had to do. So now let's say we have multiple possible factors. So we're trying to test several explanatory variables at once. So in actual studies that I've heard about, there's talk about either medication being effective, talk therapy being effective, or maybe it's more effective if you do both together. So the factors could be like a particular drug, such as Prozac. I don't know. This is a brand name. I don't know what the generics are called. Or talk therapy. The factor levels, let's say, are like whatever the correct dose is. I'm assuming the dosage is based on like body weight or something. So I think there's like a single dosage of Prozac. So it's sort of a yes or no, correct dose or no dose. But then talk therapy could be the same, once per month, twice per month, or 4 times per month. Okay, so what would the treatments look like? It's typical in a multi-factor design to have treatments that are all the possible combinations of the different factor levels for your factors. So here we've got 2 factor levels for Prozac, 3 factor levels for talk therapy. So let's make a 2x3 table here, where this would be medication is either a yes or a no. And this is talk therapy, and it's once per month, twice per month, or 4 times per month. And so then this would be treatment 1, treatment 2, treatment 3, treatment 4, treatment 5, treatment 6. So in this case, my study isn't blinded. It isn't single blinded because I'm not trying to use any placebos here. All my treatments, and there's no control group. All my treatments are just different combinations of the factor levels. If I wanted to, I could have a single control group out here that just does nothing. I could have a single control group that does nothing, but I could also add another row here to medication. So I could have, oh no, sorry, let's not do that. The no could be a could be a placebo no. So I could be giving them a sugar pill instead of actual Prozac with like active ingredients in it. So either could be an option. But the point that I wanted to bring out was this idea that you can combine multiple treatments together as different combinations of factor levels. Okay, I think that's it. In your activity this week, you will be thinking about how to blind different possible experiments, and you'll be practicing writing down an experimental design similar to this front side, and we'll have an actual format for you to do this to make sure you have all the information you need. All right?